Today we're going to look at translations. It's a special form of change of a figure in the coordinate plane. Our learning target today is I can translate a figure and write a rule. Our essential question is what are the properties of the four types of isometry or rigid motion? Feel free to stop the video to get that all written down. So a translation is a transformation, which from our last lesson, remember, just means change, that moves every point of the figure the same distance in a given direction. Okay. So we've got two examples down below. On the left, we have two triangles, and there's a before the move and an after the move. Before the move, we call that the pre-image. So pre means before. Once we move the image, then we call it the image. Notice that every vertex is moved the same distance, the same direction. The pre-image can live anywhere in the coordinate plane. So the figure on the right shows the pre-image is now on the right. And we're going to move to be our image, we're going to have to move twice. So when we move, if we go to B prime, if we move diagonally, we call that a vector, which artists use all the time. That's what they use in animations to make films and cartoons. But in Geometry 1, we're going to use our coordinate plane like a game board, and we're going to only move left, right, and up and down. So if I go from B to B prime, I first have to move left 1, 2, 3, 4, 5, 6, 7, 7 units left. So it's like on the x-axis. On the x coordinate, I'm moving left 7, and then I have to go down, so 1, 2, 3. So on the y coordinates, I have to go down 3. And here they show it in words too. So this figure slides 7 units to the left and 3 units down. Okay. Explain whether this, I guess here's the answers, but explain if the transformation is a translation. Okay, so we're explaining. So we're going to explain in words if the transformation or the change is a translation or is it being slid. So here we see bricks on a wall, and it looks like they're just moving left, right. They're moving like left and up. And so we say, yes, the figure appears to slide up, down, left, or right. The figure on the right, we see a smiley face that appears to have a line of reflection and seems to just be flipped. So no, the figure appears to flip across the line. Okay, before we can use animation of like fishes in Finding Nemo or anime, we have to start with basic images. So let's start with a three-sided shape, a triangle. And our pre-image is on the left. I know that because the vertexes, so the point T is just a capital letter T, but here T prime has like a move. It's saying I moved once. It must be a Friday. All right, so remember that vectors go on the diagonal. They can go in any direction, but in Geometry 1, we can only move using the game board of the coordinate plane. So to move from the pre-image t to the image t prime, I have to move 1, 2, 3, 4, 5 units right, then 1 unit up. So to say that in words, to describe the transformation in words, we just say 5 units right, 1 unit up. Okay, got 2 more examples. So here we're going to graph. We're actually going to graph now. We're going to graph our translation by counting. So here's our directions. Our translation is we're going to go 4 units left. So left is my it's my x-axis. So it's like I'm taking my x ordered pair and I'm subtracting 4 from it. So I'm going to go 4 left and 2 units down. So my y-axis is my up and down. So it's like I'm taking my y coordinate and subtracting 2. So let's see, if I have A, B, and C, I'm just going to take every point and I'm going to count 4 units left. 1, 2, 3, 4, and I'm going to make, oops, not quite yet. I'm going to count 4. 1, 2, 3, 4, and 2 units down, 1, 2, and that's where I'm going to make my vertex. And so instead of A, I'm going to say A moved once. I'm going to do the same for B. So B, I'm going to move 4 left, 1, 2, 3, 4, and 2 units down. And I see that B landed exactly on top of A, and that's okay. That's just the problem that we have. Now I'm going to take point C and move it 4 units left, 1, 2, 3, 4, 1, 2, and that's my vertex and C prime. The thinking dots, if it wasn't a video, kind of these moving dots, I normally wouldn't make those, but I wanted you to see where I was counting. And we're not done yet until we make our triangle, and there we have it. Okay. One more, and let's put it all together. So we're going to graph the translation using notation. Notation are just symbols. So we see we have our pre-image. Oops, oh goodness. We have our pre-image, and we see we have any ordered pair. So this is a rule we can use on any ordered pair. So my x's are my left and my right. And so if I'm subtracting 1, that means I want to go left, 1. My y's are my up and my down. So if it says plus 2, I want to go up 2. Okay, so let's see, we've got a quadrilateral now because I've got 4 sides, A, B, C, and D. My coordinate for A, if I start from the origin, I'm not going left or right any, but it looks like I'm going 3 down. B is 1, 2, 3 to the right, 1 up. C is 2 to the left, 2 up. D is 3 to the left, 3 down. Okay, so that's our starting points, and we're going to make a change. We're going to move, we're going to slide or translate these, and if that's my x and my y, I'm now going to take my x value and subtract 1, and take my y value and add 2. So my x value is 0, so I'm going to take 0 minus 1. In B, my x value is 3, so I'm going to take a 3 minus 1. Negative 2, so negative 2 minus 1, and D is -3 minus 1. Okay. And next, I see I'm going to take my y value. So in A, my y value is -3. And I'm going to add 2. I'm going to take 1, add 2, take 2, add 2, and -3, add 2. Okay, so our final image point, so this is going to be A moved once, is going to be -1 for my x value, and -3 plus 2 is -1 for my y value. I find my other points. B moved once, it's going to be 3 minus 1 is 2, 1 plus 2 is 3. C prime is going to be -2 minus 1, so it's -3, and 2 plus 2 is 4. D prime is going to be -3 minus 1 is -4, and -3 plus 2 is -1, and now we can plot those. Okay, great. So if I look at A prime, it's -1, -1. So from the origin, I'm going to the left one and down one. That's my new, it's my new A moved once. B moved once is excuse me, 2, 3. 1, 2, 1, 2, 3. So there's B moved once. C is -3. 1, 2, 3, 4 up. 1, 2, 3. So that's C moved once, and D is -4, -1. So that's D moved once. And if we connect our vertices, we see that we have a rigid motion. We have a rigid motion, meaning the shape has not grown or shrunk, and it's just slid along the coordinate plane. Okay. We've got some U-try problems that match all of our examples in this video. Just try it, and we'll check in next time we see you. Bye.